This is Mrs. Palmer-Quay with the second video for Module 6. In this video, I'm going to continue our discussion of stoichiometry by looking at limiting reactants. Remember that mole ratios show you the relationship between any two substances in a chemical reaction, and that these must be balanced chemical equations to show the correct mole ratios between reactants and products. So just to remind yourself, we've got this balanced chemical equation where ammonia reacting with nitrogen monoxide makes nitrogen gas and water. And we could say that we have a mole relationship between a reactant and a product. So 4 moles of ammonia when reacted with sufficient amount of nitrogen monoxide will give you 5 moles of nitrogen gas. Or you could do a relationship between the two products, that this reaction makes 5 moles of nitrogen, I should write the word mole in here, 5 moles of nitrogen gas and 6 moles of water, or any other combination of reactants and products. So you're not limited to what two substances you're comparing. You compare any two substances in a mole ratio depending upon what you're trying to calculate. The idea of a limiting reactant comes into play if the actual amount of the two reactants involved in a chemical reaction are not equal to the mole ratio. In that case, one of those reactants is going to limit or restrict the amount of product that can be formed because the ratio is not the same as the ideal ratio found in the balanced equation. So the limiting reactant, which you will sometimes see written as limiting reagent, is what determines the amount of product that can be made. The other reactant is there in excess. There's more than enough, and it is not fully consumed. There will be some left over. So when we're talking about reactions in real life, we're concerned about limiting reactants and excess reactants when the mole ratios don't line up with the exact ratio that's in the balanced equation. So let's look at our ammonia equation, where we take nitrogen gas and combine it with hydrogen gas to make ammonia. What happens if you have 3 moles of nitrogen gas and you react them with 6 moles of hydrogen gas? Well, you know you have to have 1 mole of nitrogen, and then you would use 3 moles of hydrogen, and that would make 2 moles of ammonia. That's what our balanced equation tells us. So if we react 1 more mole of nitrogen, plus 1, we would be adding another 3 moles of hydrogen and making another 2 moles of ammonia. So at the end of this reaction, we would have used 2 moles of nitrogen gas, and we've used 6 moles of hydrogen gas, and we've ended up making 4 moles of ammonia. And you see that we had 6 moles of hydrogen gas to begin with. We've now used up all of the hydrogen gas. We had 3 moles of nitrogen gas. We've only used up 2, but we can't make any more because we've used up all of our hydrogen. So our limiting reactant is going to be the hydrogen gas. We don't have enough to finish the reaction. We don't have enough to use up any more nitrogen. The nitrogen is here in excess. There is still more, but we can't use it because we don't have any more hydrogen. Calculations with limiting reactants generally ask you to find them. So in this case, we're given an equation that tells us that silver reacts with sulfur to form silver sulfide. And the balanced chemical equation is given to you, which tells you that 2 moles of silver react with 1 mole of sulfur to make 1 mole of silver sulfide. The question asks, which one is the limiting reactant if you have 0.46 moles of silver and you react it with 0.321 moles of sulfur? So in order to find the answer to this problem, you want to pick one of these reactants and calculate how much of the other reactant you need, and then compare it to what you actually have. It doesn't really matter whether you work with silver or with sulfur, because either one will reveal the answer. So let's start with silver, and so we're just going to do a mole ratio problem, just like we were doing on the previous video. So we've got 0.464 moles of silver, and we're going to multiply that by the equivalency fraction That's comparing the mole ratio of sulfur and silver. So 2 moles of silver react with 1 mole of sulfur. If you go ahead and do the math, you discover that in order to have the amount of sulfur to react with this amount of silver, you need 0.232 moles of sulfur. So 0.464 moles of silver work with 0.232 moles of sulfur. So this is how much you need. How much do you have? You have 0.321, or 312, sorry. You have 0.321 moles. You need 0.232 moles. So obviously you have more than enough. You have an excess of sulfur. So that means that your limiting reactant must be the silver. The silver must be what you don't have enough of, because by calculating how much sulfur you actually need and compare it to what you have, you can tell that what you have is in excess. If you didn't pick silver, if you picked sulfur to do this calculation, what would you find out? Well, we take the amount of sulfur we have, 0.312 moles of sulfur, and we multiply that by our equivalency fraction. Of course, we need to, since we've got sulfur here on the numerator, we want to switch it around. So we're going to have our silver on the numerator and our sulfur in the denominator. And again, if you do the math here, you will see that we need 0.634 moles of silver in order to react with the moles of sulfur that we have here. And that the 0.634 moles is less than the 0.464 moles that we have. So once again, it just confirms that we don't have enough silver, that our silver is our limiting reactant. So as you see, it doesn't really matter which one you pick to work with, as long as you can logically think through how much you need compared to how much you have, as it is revealed by the equation. So that covers what I need to say about limiting reactants, and we'll be continuing to work with these stoichiometry concepts as we go on in this course, working with mole ratios and limiting reactants, and always with balanced chemical equations.